All right, this is 3.4, chapter 3, 3.4, and the focus is on area of a parallelogram. So the vocabulary that we're going to consider is actually the word parallelogram, what that means, and then what the base of a structure or figure is, and what the height is. Not too tricky, I don't think. So parallelogram, and this is an example of what one looks like. Parallelogram is a four-sided figure, okay, four sides only. The opposite sides are parallel, so this side and this side are parallel to one another. This side and this side are parallel to one another. Okay? And then all of those sides, or each adjacent side, this one and this one, are of equal length, and this one are of equal length. So they're pretty standard. Okay, so that's what a parallelogram is. It's a perfect definition of a parallelogram. So some parts that we're going to consider, we're eventually going to get to finding the area of a parallelogram. And the area, as it says here, is the amount of space within a two-dimensional figure. So this whole space inside, like everything inside. Like last year you talked about perimeter, which is just how much is the outside together. That's where you measured it and then you added it all up. But with area, we want to find this how much space there is on the inside of a two-dimensional figure. Okay. Next year you find the area, or volume of a figure. But it's a three-dimensional figure. So that's a little bit a step above. So area is just of a two-dimensional figure, this whole space inside. Okay, so the base. So when we consider the base, that is the bottom side of a figure. So that's this right here. Now, if this figure was in a different orientation, let's say it was like that, then this would be our base. It doesn't change anything. Nothing gets changed, and your measurement would be exactly the same afterwards. Okay, but the base is just the bottom side of a figure, and the height is from this point. Actually, I'll draw it. Is from this point right here. Oh, that's pretty messy, hey? To right there. So from that point to that point. Actually, my next picture shows it. So let me just get rid of that. Okay, so right here. So there's our base, and there's our height. And that's all you really need to consider when you're finding the area of a parallelogram. Now, before I go on to calculating that and showing how we figure that out, I want you to look at this here. So here's our parallelogram. Now, where's our ruler? I want to show you a little trick here. So, oops. Okay. Oh, there it is. Okay. How am I turning this? There we go. There we go. Okay, so if I took a line, just see if I can illustrate this for you, and let's cut this piece. Okay, so we cut that piece out, and actually let's get rid of it, right? So let's pretend that that's gone. Okay, so pretend that piece doesn't exist. And we take that piece and we actually put it on the other side, right here, right? So we cut it out and we stick it over here. Guess what? It's a typical rectangle now. It's like what we started with before. Sorry, I'm kind of slow with the ruler. Gives you time to process though. Right? And so we take that figure and we slap it on the other side, and we just have a regular, we just have a regular rectangle now. Nothing different at all than what you were dealing with in grade 6 when you did length times width, right? So we're basically doing the same thing, except with the parallelogram. It's slightly different, but you should get the same type of calculations. Okay, so let's go back to this page here, and I'm going to show you an example of how to calculate it. So here's a parallelogram here. We have a base, we have height, and then I've thrown another number in here, which is probably not accurate, but it's the measure of a side here. Now, which parts are we going to actually use? We're going to use 8 centimeters for the base, 4 centimeters for the height. That's all we're going to use. Here's the formula that we're going to use. So last year you used area equals length times width. This year and for the rest of your existence on this planet, you're going to use the formula area equals base times height. Okay, and so our abbreviations or symbols for that are A for area, B for base, and H for height. Okay, so then we just plug the numbers in. So we have, here's our base, right, 8 centimeters, so we put 8 centimeters in there. Don't forget your units. And we have our height of 4 centimeters, so we put 4 centimeters over there. And you have area equals 32 centimeters squared. When you're looking at a two-dimensional figure now, we use the units squared. And in this case, it's centimeters squared. It could be meters squared, could be kilometers squared, could be a lot of things squared, whatever you're measuring your distance as. Okay, so this is your basic example that we're looking at. Okay, here's another one right here. Now, what is your formula? That's the first thing you get down is your formula. So what's your formula for area of a parallelogram? That is correct. Area equals base times height. A equals B times H. Right there. So what is our base? What is the measurement of our base? That is correct. 10 centimeters. Very good. And our height is 6 centimeters. That's correct. It's not 8 centimeters, right? Because that is the length of that side. It's a little bit different. So it's 6 centimeters. Okay? So we have 10 centimeters times 6 centimeters, and that gives us a whopping 60 centimeters squared. 60 centimeters squared. And that's how you find the area of a parallelogram. And that is the end of my story.